Baguio City is among the top 20 highly urbanized cities in the Philippines. It is home to about 350,000 residents and hosts around 73,000 built-up structures. The city contributes significantly to the bulk of the total building construction in the Cordillera Administrative Region. And most of these are residential, followed by construction of commercial purposes. However, these buildings are at risk to the several potential earthquake generators surrounding the area. The proximity of active faults to Baguio City puts its structures at risk to ground shaking hazards. An earthquake's effects vary with the softness of the sediments. As seismic waves travel through the ground, they move faster through hard rock than soft soil. When waves transition from hard to soft earth, they increase in amplitude or size. The same principles also applies to sediment thickness. The deeper the sediment layer above bedrock, the more soft soil there is for the seismic waves to travel through. The presence of overlying soft soils means bigger wave and stronger amplification on site. The ground has its own period of response to shaking. Soft and deep sediments produce longer periods of ground response, while harder layers with little to no sediment cover have short period values. Similarly, all buildings have a natural period of vibration. With the same concept, it is the number of seconds it takes for the building to naturally vibrate back and forth. If the fundamental period of the building matches the natural resonant period of the ground, it will undergo the largest oscillations possible and suffer the greatest damage during earthquakes. One of the fastest ways to calculate the period of the building is through the formula provided in the National Structural Code of the Philippines, or NSCP. The chart on the right also gives a rough estimation on the relationship of building height to its period. Determining the period of the grounds and other things in site-specific evaluation need to be done first. It is also important to note that Baguio City has an irregular topography, and the properties of the subsurface layers in Baguio tends to change significantly over a short distance. Hence the call for a site-specific survey. The PSSIT project uses an alternative type of geophysical survey method that employs the use of portable seismograph. This survey method is a non-invasive, since there will be no need to drill holes on the ground to acquire data. The instrument will only be placed on the surface of the ground and will record vibration to extract subsurface properties. The survey method uses a passive and active approach to measure ground vibration properties. Since the equipment is portable, it will not require any heavy machineries or massive workforce. A person or two can operate the instrument and complete the survey in less than an hour. The resulting data from the project includes determining the depth of overlying soil layers and their corresponding shear wave velocities, as well as the resonant period of the ground on the site. Through these, we can produce good estimates of amplification levels and determine areas that certain types of building might resonate with. The output of the project will incorporate a microzonation map and will be published as a site response atlas of Baguio City. This is a detailed compilation of hazard maps depicting the site response and earthquake ground motion levels of Baguio City. The list shows the map that we'll include in the atlas. One of the main output is the short period microzonation map, which shows the resonant period of ground that may affect the building on site. Another main output of the project is the VS30 or shear wave velocity map of Baguio City. VS30 values show the average shear wave velocity of the upper 30 meters of the ground. This is used by design engineers to identify the soil profile type on site as defined in NIHERP recommended provisions for seismic regulation of new buildings and other structures. The results of the project will formally introduce the city government of Baguio and other concerned stakeholders to an official launching and turnover ceremony. The event will also include lectures on how to interpret data presented in the maps. Overall, the endeavors of the project would largely contribute to the seismic risk assessment of local administrators in land use planning and proper seismic design implementation of structures from the effect of ground motion on Baguio City's irregular topography.